I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up. I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up.
Hello and welcome to the Annoying Tech Truth podcast. You probably noticed the name change, and there's a reason for that. Now, the community is quite small at this point in time, but it does exist. So I'm getting feedback from people every now and then. And one of the things that was mentioned to me is that the episodes are quite interesting because they show a side of the tech world that is not really shown by other people. And the message could be annoying sometimes, but it's still true. And there is a movement of making everything look easy and very, very easy in terms of it's easy to become a software developer. It's easy to be very well paid. You get all these, benefits. You've got your ping pong tables, your whatever, and you don't work a lot of hours and all that. So the good aspects are always emphasized to an extreme. The reality, however, is that there is a darker side as well, and this is what I'm interested in, showing both sides, not just one. So if you want to make a decision in whether you want to become a dev or not, if you want to look at progress in your career or not, you need to know both sides, basically. You need to know everything, not just the positive aspects of it. So from that point of view, the Annoying Tech Truth seems like a much better fit. So I'm going to be trying this for a while. Now, I'm still in the experimenting phase, to be honest. The name is not entirely there yet. There's still a lot of stuff I need to learn, which I'm aware of, but we'll see how that goes. Like, for example, I'm terrible when it comes to creating thumbnails, so I'm going to need to do something about that. But anyway, I probably should do a separate episode just on this subject alone because there's so much to talk about. So anyway, let's move into the subject of the current episode, which is ORMs versus SQL. Now, what is an ORM? A very basic definition would be an object relational mapper, hence ORM. What does that mean is we are trying to find a way to make our life a bit easier when we work with a SQL engine and do the boring stuff in an easier way. What does that mean? Well, if you've been in this field for a while, let's say 10 plus years, you probably remember how we used to do things before ORMs became a thing. So we used, for example, in the .NET world, we used ADO.NET, which was the way to connect to the database. It wasn't very interesting. It wasn't hard to use, but you had to go through a number of things in order to make it work. So you had to be very careful how you specified your inputs, your parameters, the types, sizes, all that kind of stuff that you had to manually specify. And that becomes boring very quickly. So once you do it a couple dozen times, you probably going to wish there was another way of doing it. So after you did that, then you execute your SQL, which and it meant you had to create the SQL string that you would execute. And then you would get your results, and you had to do something with that because they were all like basic objects. You didn't know what type they were. You didn't know anything. So you had to be very clear in specifying, oh, that is an int, or that is a string, or that is whatever. So you had to go through this game every time you wanted to run something. Now, I completely understand something like this becomes annoying very, very quickly when you keep doing mindless, boring stuff day in, day out. So ORMs came around, and the idea was that you don't have to specify a lot of time working on your inputs and your outputs. You just say, okay, use this, and execute that, and then take the results, custom automatically for me to something, and then I don't have to worry about any of this stuff. And the connection to the database would be done in a very, very interesting way. And that was basically it. So you had your, in the beginning, you had your nhibernate, for example, which was a bit clunky, but it was, one of the first ORMs around. Its configuration was done in XML, which was quite big at the time. Everything was XML. Now these days we're talking JSON, we're talking APIs, so JSON is big. XML not so much. And for that reason alone, it was actually quite clunky. Now XML can do a lot of stuff, as you well know. It's not just a way of expressing data. There's a lot more to it than that. But it wasn't really needed for what we wanted to do. It was just a way to do things at the time. Now after that, other ORMs appeared. So you had your entity framework, and which over the years it became quite a bit of a beast, because obviously they kept adding functionality, and it got to today where it's entity framework. It does a lot of stuff for you out of the box, but it's an entirely ecosystem built on top of a SQL engine. And I would argue that probably does a bit too much, and that is coming from a desire to hide the functionality of a SQL engine up to a very high degree. So this is what we're talking about today: ORMs versus SQL. Now, you probably noticed very well that there is always a bit of a war between these things when it comes to discussing which one to use. You could have two sides quite vocal about it. Yes, you definitely should use an ORM, or no, you should be using SQL. And there's very little common ground between the two sides. Now, one thing I always mention is to keep an open mind, because there isn't just one truth. There isn't just one way of doing things. There are multiple ways of achieving whatever you want to do. So you might be in a position where you use both, which I have. There's no reason to be just on one side and then fight the other side and trying to explain why your side is better. Now that happens quite a lot in the tech world. People are very fond of their points of view and their opinions, and they hold this idea that their opinion is always correct. Whatever they say, their side is always correct and the other side is dumb. And I've seen that myself. So I remember a few years ago I had a conversation about this specific subject, and I always advocate for learning SQL for a number of reasons, which I'm going to go into a bit later. And I remember being accused of being old school, not too smart, hanging on to the old ways, and learning a dead thing, which was basically SQL. Now, of course, I take these kind of statements with a bit of with a huge grain of salt, really, because SQL is not going anywhere, right? We're using it, and we have been using it for a while. A relational database is useful in many situations, but not always, but in many situations. So to say that it's out of date is a bit of a stretch. It really isn't. In fact, we see more and more things appear in the relational side, but also in the other side. Now, I'm not going to talk too much about NoSQL at this point. I'm thinking there is enough material to have an entire episode dedicated to SQL versus NoSQL. So I'm probably going to leave it to that. Now, let's go back to ORMs. What issue do I have with ORMs? Well, there's quite a few of them. Now, I've been using Entity Framework for a long time, although I did stop using it a few years ago. And yes, I haven't actually been touching Entity Framework much at all. The main reason for not using it is because I didn't like the SQL it generated. Now, if you work with SQL quite a lot, then you've probably heard of a database normalization, right? So that means you basically separate your data in small chunks rather than repeating the data all the time. So let's say, I'll give you an example, right? Let's say you have a products table, right? And each product has a product type. So your products table would have something classic, like a name, for example, maybe a price, and maybe a product type, which could be a string. Like, for example, it's a I don't know, a screen, or it's a mouse, or whatever, right? But the point is, the product type is a piece of text. Now, as part of database normalization, we say, well, actually, let's not do that, because what we're doing here is we are repeating the same bit of data a lot of times. So if you, at some point, you want to update a a product type from screen to DV, for example, then you would have to run an update statement on a lot of fields and try to get the right ones. And you have to do many updates basically. So instead, we're going to create a product type table where we put these things. Let's say number 1, we have screen. Number 2, we have a mouse. Number 3, we have a wheel. I don't know, something. So your products table now, instead of the piece of text, uses the ID of that type. And that's what it means to actually normalize your data. You go like this and you repeat the least amount of data possible. Now, one thing that I've noticed myself, but like I said, keep an open mind because I haven't been using NT framework in a while now, so things might have changed. But the point is, when you had a highly normalized database where you actually took care of these things, the SQL NT framework generated was horrendous, completely inefficient, and which simply linked to the same tables over and over and over. It would do way too much and would take way too long to do this kind of stuff. Now, of course, you could argue that, okay, you don't have to do that. You could write your own SQL, but that kind of defeats one of the big attractions of NT framework, which is exactly that. Now, we all know NT framework does quite a lot of things, and you've got your database contexts, and which are quite big objects, and you have your entity tracking and other things as well, and migrations, and, well, many other things. Now, what I like about SQL is simplicity. If you work in this field, if you're a software developer, I think that you should have what I call this technical curiosity. And that means you should always try to understand what happens under the hood, right? Because my firm belief is that you cannot be a software developer if you don't understand SQL. Okay, backend developer, let's say. If you're a front-end developer, you probably don't care too much about this. But if you're a backend developer, then you do. And if you come to me and say, well, look, dude, I think you're wrong. Actually, there's no need to learn SQL. Well, I'm going to look at you and think, well, you're like a mechanic who doesn't understand how the car works. It can't work, basically. It doesn't function. So one of the things that differentiates good developers from not so good ones is their desire of learning how things work under the hood, how your frameworks work under the hood, how your language works under the hood. And if you don't have that, then I can't take you seriously as a developer. That's basically the annoying truth. There you go. We found a good use for the name already. So that's how I'm looking at it. Now, you also have the code first or database first approaches. Code first appeared after NT framework introduced its way of connecting to the database and creating all the objects for you. So if you've used NT framework, you know, and especially in the past, you would connect to the database, you would connect to a table, and the NT framework would generate a class that would mirror that table. So you had this relationship, this object mapping between a table and a class, and it was created for you automatically by NT framework. Now, that was a nice thing until you realized that if you used those entities, you were basically tied very closely to how NT framework worked. So every time there was an update, every time something happened, you would need to make some changes and make sure things still work. And if you wanted to make some changes and maybe use something else for specific parts, then that wasn't very easy because, you know, your objects were created by NT framework. And you always had this dependency and very little control on how things were done. So when this happened, I made a point of not using directly these classes created by NT framework, but instead have an extra layer of mapping where I would create my own objects, which I call DTOs, which is data transfer object, and those would make the connection between the database and what I wanted to show and work with. The idea was that I could even take NT framework out completely and I wouldn't lose anything. Because that's the thing, if you start doing that and you start using the NT framework classes, and then one day you decide, well, actually, I don't want to use NT framework anymore, I want to use something else. At that point, you'd be stuck because you would lose all the classes that you used to work with. So there would be quite an effect on the code base. And this is exactly what I wanted to avoid. Now you could come and say, okay, dude, how many times have you done that? A few times, actually. Not a lot, but a few times I have done that. mainly because of the performance of the thing. So I was on a project specifically where I had to remove NT framework because it was too slow and the SQL generated was horrendous. Now, granted, that was some years ago, so that's probably not the case now. But that was a real thing that I had to do. Just get rid of it, replace it with standard SQL, basic ADO.NET, and just go straight to the database and do things. And the improvements, the speed improvements were incredible. It went from the project went from not working at all or taking way too long, which resulted in timeouts, to being very responsive and very quick, which was what the purpose of the exercise was. And of course, Entity Framework had other problems over the time. Like, for example, it wouldn't work well with when you try to maybe do an insert of a lot of entities. Now, I don't want this to come as I'm hating on Entity Framework. I'm not. I've used it for a number of years, and it can be quite useful. But I do like my databases, and I do like to have control over what's happening, and I do want to write my own SQL. And that comes back to what I said before. I think every backend developer should know how to use SQL very, very well. Now, I understand the difficulty. It is a hard one. Learning SQL is not that easy, mainly because it requires a shift in the way we look at things. You operate on data, not on just simple objects anymore. So the paradigm shifts. Now you have to think, okay, I want to work on some bits of data, which means I have to select that data, and I'm going to do something with it. So everything is basically focused on data, because that's the point of the engine, right? So that's the paradigm that I'm talking about. And once you realize that, you'll realize that now you can start using the programming language, which is T-SQL, and you can do certain things, but they're all focused on the data and nothing else. So that's the important bit. Now, if you use something like Microsoft's SQL, it has a lot of optimizations that would make our life a lot easier. You've got your execution plans, so you can see what's going on. When you write some SQL, you've got your optimizations right there for you. It can suggest what indexes to apply to your data to make your queries a lot better and a lot quicker. It can do quite a lot for you out of the box. And this is why I like it, because you get to work with the thing, you can see what's going on, and you can work on optimizations. And it's a much nicer experience than trying to work out how to do it via a framework that's built on top of your engine. And that's the problem. I'm not a huge fan of frameworks. They have a use, but in most cases, I prefer something else. Okay, so you might come and ask, okay, then if you don't use anti-framework, then what do you use? You must use something, right? And you would be correct. Yes, I do use something. I like Dapper quite a lot because it's very basic. It doesn't do much. It gives me a way to specify my inputs, my SQL, which is just a piece of text, and then I can say, okay, take the results and map them to something, to this class. And as long as the field names match the fields in the class, then that mapping happens very quickly without any errors. So it takes away the boring stuff from me and allows me to focus on what I care about, which is the SQL bit. So that's what I do. I use Dapper. There you go. I don't need context. I don't need anything complicated to do this. Now, the main reason for this episode was to talk about the stance that people have. So what I would like everyone to think about is that you might hold the opinion that your ORM is the king and SQL is out of date, which I already explained I don't subscribe to, and I've given you my reasons. So I would encourage you to think about that. There are times when you want to use something very close to the metal because you want performance and because you want to understand what's going on. Nothing wrong with that. And there are also times when the performance is not that important. So the fact that the query takes a couple of seconds more to execute doesn't really make any difference, and that can easily happen. In that case, you want something easy to use. You might want to use Entity Framework. You might want to use something else. Then you're perfectly fine to do that. My point is, there's no need to take a side and say, no, I don't want to learn SQL. I'm only going to use ORMs. And there's no point in taking the other side, which says, well, I love SQL, and that's the only thing I'm using. I'm not going to use anything else. As usual, the truth is somewhere in between. And you probably find that what we say always is true, which is use the best tool for the job. And sometimes it might be pure SQL, or it might be an ORM. And that's the point I want to make. Try not to take sides and try not to think like you're part of a cult, because that's what happens. These things becomes like cults. You identify as an ORM lover, a SQL hater. That's a cult. And the other one is true as well. SQL lover, ORM hater. That's another cult. And then you get clashes between people who argue about each other. But when they argue, what they forget to mention is their context. They might both be right from their point of view based on what they're working on. It doesn't mean they're right always, though. They are correct for certain scenarios. But, if that's all you do, if you use that one scenario all the time, and that's pretty much the bulk of your work, then you're never going to know the other side. You will never understand why the other bit is useful. Now, I'm here to say, well, think about it and try to do things in a different way, maybe. Try to get out of your one context and see what's going on, because the other side has a very, very valid point as well. And that's the main point of the podcast. We need to stop these holy wars of whatever they are. I mean, we can't even agree in 2020 to see what's best to use. Is it a tab or is it space? In our editors, should I have 4 spaces or should I have 2 spaces? And you actually have people arguing over this and many other things as well, which I don't like. Because if we work in tech, we're supposed to be smart people. Everybody's smart as far as I'm concerned, which means we need to be able to see all the sides, not just one. So when you start insulting someone else because they are on the other side of the fence, at that point I have an issue. And that's the bit that I do not want to have. That's the annoying truth for this episode. Anyway, let me know what you think. This, as usual, will go on YouTube Locals and the various podcasts. I do have one tiny little request, which is, and it's the first time I'm doing this, and I don't like it. Trust me, I do not like it. But I have to, because it would be nice to actually grow the channel a bit more and a bit quicker if possible. So don't forget to like and subscribe. And if you think it might be useful to other people, please do share with other people. Well, let's see what they say. Anyway, thank you very much, and I shall see you next time.
I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up. I don't ever slow up, no I don't take shit.